So first thing we need to do is remember from the periodic table what we were looking at. So we've got the two different things. We've got the groups, which go from top to bottom, and then we've got periods that go from left to right. Okay, so we're starting with, we got groups that go this way, groups go from top to bottom, and then the periods go from left to right. Okay, first thing we need to do is with our three colors, we need to make a key so that we know what we're looking at or what our three colors are. So with your first color, pick whichever color you want. Your first color, you're going to mark, and these are going to be your metals. Your second color is going to be your nonmetals. And your third color are going to be your metalloids. Okay, so when we're looking at this, we're looking from one side to the other. We start with metals. This zigzag line right here is when we start to see our combination of metal and nonmetal, which gives us our metalloids, which have, they're not metals, they're not nonmetals, but they have properties from both. And then to our nonmetals on the other side. The one exception to this is hydrogen. Hydrogen on this side, right here, is a nonmetal. Okay, so I will be coloring in hydrogen. It is a nonmetal. It is over here because this group right here is the most reactive metal group. So this first group right here, these are called the alkali metals. And that's this first group, this first column going up and down. These are the most reactive elements in the entire periodic table. That is why hydrogen is included in there, because hydrogen is also very reactive. Okay, so with these being the alkali metals in here, so I've got lithium, sodium, potassium, rubidium, cesium, and francium, or francium, I don't know, I think it's francium. Okay, these are all metals. So they are going to be all your second or your first color, whatever color you deemed was your metals. Hydrogen, again, stands out of those. It is not an alkali metal. Hydrogen is a gas. Some things that you know that we know about alkali metals is that they have one valence electron out in the electron cloud outside of the nucleus. They are shiny and usually silver in color, and they are extremely soft, like their density is not high. Usually they can be cut with a knife. Next group would be group 2, and these are called the alkali earth metals. So as we go from left to right, we also see that these get less and less reactive. Okay, these alkali earth metals have two valence electrons. They're silver in color, and they are also denser than alkali metals. Okay, so if alkali metals are metal, alkali earth metals are also metal. So we are going to color these in with the same color we did for the other metals. So our next section is this little section right here. And these are called our transition metals. It goes down to there. Don't look at that other one. Okay, so it goes these little section 3 through section 12. These are all our transition metals. Now, they have a moderate range of reactivity and similar properties. They're generally shiny, and we can tell that they are good conductors of heat and electricity. So your transition metals are very good to conduct heat and electricity. Now, another thing that you'll see is if you look down here at element 57, lanthanum, between lanthanum and hafnium, do you see that there's a jump? It goes from 57 to 72. Well, those right there, they're not in the table. They are these that are right below the table. Okay? Those were taken out in place at the bottom so that the table wouldn't be so wide. The elements in these two periods share many of the same properties. Okay? The lanthanides, which are these right here, lanthanides, they are generally shiny and reactive. The actinides, which are these right here, are all very reactive. They're actually radioactive, and therefore they're unstable. Now, these last from 95 over to 103. These are man-made in a lab and not found in nature. So 95 all the way through 103. Now, all of the transition metals, including the lanthanide and the actinide series, are all metals. So we're going to color all of these our metal color. So as you see right here, these are the ones that we are going to color in, the transition metals in the middle and the lanthanide and then actinide series on the bottom. So it should look like this when you're done with that part. Okay, so this next part gets switched up a little bit. In the boron group, so in 13, 14, 15, and 16, they're all named after their top element. So this is the boron group, the carbon group, the nitrogen group, the oxygen group. Okay, we'll talk about 17 and 18 later. But for now, 13 through 16, those are all the names of their groups. This is where the zigzag comes in with the metalloids. Okay, now as far as metals go in group 13, the boron group, all four of these below the line, aluminum, all the way through thallium, are all metals. And that leaves boron up the top, that is a metalloid. It's orange on mine. Okay. So in the next group, I'm going to have a nonmetal. So carbon is a nonmetal because carbon is a gas. Okay. My metalloids are silicon and germanium. And then tin and lead are both metals. Okay, so let's just finish coloring in the rest of the metals for right now. So we've only got 2 more metals left, and that's bismuth and polonium. Then following our metalloids, arsenic, and antimony, I think, I don't know, I'm probably saying that wrong, and tellurium, and then astatine. Those are all of our metalloids. The rest from here out are all going to be nonmetals. So a couple of things left. So we've got our nonmetals over here, our metalloids there. So first thing is that this row 17, or group 17, not row, excuse me, are called the halogens. Okay, these are the ones that are called salt formers. Okay, those mixed with other things are salt forming. Then group 18, these are called the noble gases. These are the noble gases. Of these were the most reactive on this end. On the other end, these are the least reactive.